All right, so this is going to be a quick video that just shows how we'll use factoring to solve quadratic equations, right? So what we're going to be using is called the zero product principle, right? And all that basically means is anything times zero is zero, right? So you'll see that here in a second. So right here, if I try to solve this equation with conventional means, uh, namely just quote unquote getting x by itself, I'm not going to have much luck. So what I want to try and do first is factor this quadratic using AC grouping in this case, because I've got an a term that is not equal to 1. So 12 times negative 10, that's negative 120. The factors of which that would combine to give us negative 7. I'm going to have to think on that. Let's see, 120, 20, and 6. Hmm. So I am not by any means the master of this. 15 and 8. Yes, those are going to be my factors that I want to use. So I'm going to use negative 15 times positive 8. So negative 15 times positive 8 gives me negative 120. And negative 15 combines with positive 8 to give me negative 7. Right? So that's going to give me uh, 12x squared minus 15x plus 8x minus 10, and we're still set equal to 0 here, right? Then, of course, I know the next step to this is to group and factor. So here I'm going to factor out 3x, and that's going to leave me with 4x minus 5. Here I'm going to factor out a 2, that's a plus 2, and that's going to leave me with 4x minus 5. And I see I'm going to end up with 4x minus 5 times 3x plus 2 equals 0, right? Now, what we're getting at here with the zero product principle, right, is let's say I had, x plus 1 times x plus 2 equals 0. Well, there's two solutions here to this equation, right? If I FOIL this out, well, of course, I would get x squared plus 3x plus 2, right? So that right there tells me it's quadratic. There's two solutions. And just looking at this, there's two things that would make us end up multiplying by 0 and making the whole thing be 0, right? So first off, I know one of my solutions is negative 1, because if I plug in a negative 1 right here, negative 1 plus 1 is 0. And then 0 times anything over here is going to make this a true statement, right? So I know that's one of my solutions. My second solution is going to be negative 2 for the exact same reason. If I say negative 2 plus 2 here, right, that's going to be 0. And 0 times anything is going to give me 0. Okay, so I can use that to my advantage right here, right? Except here it's not quite so obvious. Okay, I can set them individually equal to 0. So I can say this one, for example, 4x minus 5. Well, what makes this guy 0? I don't know. Let's find out. So I'm going to add 5 and divide by 4. I end up with my first solution is positive 5 over 4. And I say my first solution, so that means x1, my first solution, right? And then here I can do the same thing. 3x plus 2 equals 0. Right? Subtract 2, divide by 3, x is equal to negative 2/3. So x2 is equal to negative 2/3. Just like that. So those would be my two answers, right? And I know that this is correct because if I take this solution and plug it in right here, I end up with 4 times 5 over 4 minus 5. These 4's would cancel. That leaves us with 5 minus 5. And then we still have 3 times 5 over 4 here. Whoa. Okay, and 5 minus 5, well, that's 0 times 3 times 5 over 4 plus 2. And 0 times, well, it doesn't matter what this comes out to. 0 times anything is 0. So I just checked my first solution. And I know exactly what's going to happen whenever I check this second solution and plug it in here. So 3 divided by 3 is 1. We end up with negative 2 plus 2. And that gives us 0 again. So we know that it works. Okay, so then this one here, let me erase, give myself some room. This next one down is even simpler because we don't have an A term. So I don't have to do AC grouping. I can just fill in the blanks here, right? So I can say, this is equal to X plus or minus something times X plus or minus something else, right? And in this case, we see it's going to be, sorry, I had a brain fart. It would be positive 9 and negative 1, right? So 9 times negative 1 gives me negative 9. 9 plus negative 1 gives me positive 8. Okay, so and right here, just by looking, I can tell my two solutions are going to be negative 9 and positive 1. Okay, let's do another one. Okay, so I am going to have to do, well, am I? Yeah, I'm going to have to do AC grouping here. I thought I could factor out an 8 from all this, but no, I can't, almost. But what I can factor out is at least a 2. So I'm going to rewrite this as 2. That leaves me with 4x squared plus 12x plus 9 is equal to 0 still, right? Now I'll do AC grouping with what's in here, right? And 4 times 9 is 36. Okay, so AC in this case is 36. The factors of which that will combine to give us 12. That would be 6 and 6. Okay, so that's just going to factor out into 2 times, we'll have 4x squared plus 6x plus 6x again, plus 9x. Oops, not 9x, just 9. And that is still equal to 0. And then we see that we're going to have 2 times, well, the GCF here, when I do the grouping step, the GCF here is going to be 2x. And that's going to leave me with 2x plus 3. Here, GCF is going to be 3. And that's going to leave me with 2x also plus 3. Okay, so we end up with a perfect square. So 2 times 2x plus 3 times 2x plus 3 again is equal to 0. Right, and something interesting is going to happen here. Right, so this times this, right, we could say that that's squared, but we'll get into that here in a second. But first, what do I do about this 2? Right, so we still want to think of, what's making x not by itself? Well, definitely this 2 is not. So we can divide both sides by 2 real easy. No problem there. We end up with 2x plus 3 is equal to, and so 2x plus 3, I just said, times 2x plus 3. We could just say that's 2x plus 3 all squared like this. 0 divided by 2 is simply going to be 0. So that means we're going to have the same solution occur 2 times. And that solution, obviously, so if we set this equal to 0, 2x plus 3 equals 0. So subtract 3 divided by 2, x is equal to negative 3 halves. And that's all that we're going to say. X equals negative 3 halves. So this is one of those rare instances where quadratic has only one solution, but we would say that it has one solution with a multiplicity of 2, meaning that it happens twice. Okay, so that's basically what that means. So it doesn't actually have only the one solution, but it kind of does. Okay, next example. So this one's not in standard form, right? So you'll notice every one of these, 1 through 3, has been in standard form. Ax squared plus bx plus c equals 0, right? Number 4, however, is not. But we can easily make it that way, right? All we have to do is add 8 to both sides. So now I've just got x squared plus 6x plus 8 equals 0. And now I'm good. Okay, then I can just fill in the blanks. So x plus or minus something times x plus or minus something else equals 0. And remember, I can fill in the blanks because my a term is 1, right? I couldn't do that here, right, because I had an actual a term, nor could I have done that here. Just want to reiterate that. So all we're going to do here is just end up with plus 4 plus 2. 4 times 2 is 8. 4 plus 2 is 6. And that means my two solutions, so x1 would be negative 4, x2 would be negative 2. Okay, and another way you'll see solutions to a quadratic or to any polynomial expressed is, it'll just be x equals, and then there will be commas separating the solutions. So I just want to throw that out there in case you see that. Okay, last example. Again, we're not in standard form the way we need to be. So 5x squared plus 2x minus 3 equals 0. So now I'm in standard form, right? So I did plus 2x minus 3. That's where I got that from. AC would be negative 15, right? The factors of which that would combine to give us 2 would be negative 5, positive 5, and negative 3. So I've got 5x squared plus 5x minus 3x minus 3. Keep factoring. So right here and right here. So I'm going to end up with 5x factored out, x plus 1, a negative 3 factored out, x plus 1 again. That leaves me with 5x minus 3 times x plus 1 equals 0. And we see our solutions are going to be 3/5 and negative 1. And we've got them. Okay, so that's it for this video. Like always, let me know if you need anything. Goodbye.